Hello everyone. Today's episode is called The Best Agent is Often No Agent. Autonomy is a tax you pay for unpredictability you can't remove. When you're automating something, you need to look at the work before you design anything. Basically, you need to ask yourself, okay, how much of this is clean, rule governed, easy to automate, and what is exceptions? So generally, this is a general rule of thumb. Between 86 to 91% in the action of invoice categorizing or processing, 86, 91% are going to be clean, rule governed. And 9 to 14% will have exceptions. The two lanes are very different. So lane A is pre-mappable, it's PO backed. You have the price, the quantity, you have unit checked against the PO and the goods received. You can auto post it. On the other side, this with missing POs, price or quantity mismatch, duplicates. So all of these problems, the lane B is much more complex. The classic mistake, and this one is obvious here, is that you would use one agent for the whole pipeline. You would look, okay, I'm gonna use an agent for all of this, which would be a terrible idea, of course, because the moment you use an agent, you're paying for extra tokens, for model decisions, for extra latency, for extra failures, so all of those problems. And that is the point of this video. Autonomy is the price you pay for unpredictability you cannot remove. So lane B here has unpredictability you generally cannot remove. Lane A does not, so do not pay it there. So actually, Anthropic talks about this, and they say we recommend finding the simplest solution possible and only increasing complexity when needed. So this might mean not building agentic systems at all. And these are literally the guys who are selling these models. So they have the incentive of selling you the models, and they are telling you, actually, you might not even need to have an agentic system. You could actually just build workflows. Basically, OpenAI said the same thing. I'm not going to reread it. So now we come to the design question, and it is one test. It's, can you pre-map the decision tree? If yes, so you don't build an agent. If no, then an agent is worth paying the tax for it and having all that work and having all those guys for unpredictability. And all of this is not mine. This is actually coming from Anthropic's own test. And they say, verbatim, agents suit open-ended problems where it's difficult or impossible to predict the required numbers of steps and where you can't hard code a fixed path. So it's not even for me. They even tell you to not do this. So what does the tax actually cost? What's the tax of having a agentic system? You have 3 lines, and which are different from each other. Some are backed with intuition and some with evidence. But you can argue about that in the comments. I will just give my opinion. Part of this is my opinion, of course. So, one number, which comes from Anthropic's own production, agents typically use about 4 times more tokens than chat interactions. 4 times, and it's for the same task, and this is before any addition of multi-agent layer. Second, and here I have to be straight with you, there is no industry standard number for single call versus agent. Anthropic does not publish one. What exists are measured examples. In one study, 3 agent settings ran 3.9 seconds to 38.43 seconds on the same task, a 3 to 6 times slowdown. The durable claim is not a constant. It's a shape, so latency scales with the number of sequential model calls. Then it's the amount of errors. And this one is backed by numbers, but we can discuss it a bit. So if you have 95% success rate per step, problem is that at 5 steps, you'd have 77. At 10, you'd be at 59, 20, 36. And this is just simple arithmetic, because at each time, you'd have that 5% is, you're gonna be basically multiplying 0.95 at every step. because that's the odds of failure. Of course, you can use retries, you can use cascades to avoid this, but generally, the more steps you have, the more you would have cascading errors, the more problems you would have. So why trust the intuition at all? Why trust what I'm saying here? Because actually, Anthropic states the mechanism directly. It's the autonomous nature of agent means higher costs and the potential for compounding errors. And it's actually measured by METR, and it says that near 100% success on tasks a human does in under 4 minutes. So if the task is about 4 minutes, it's amazing. It has near 100%. Under 10% when you're at 4 hours. This is a measurement. It's very rough. It's very general. Problem with all of these statistics is that, or these numbers, is that it's very subjective, and what could be success for someone might not be for someone else. So generally, a very good rule of thumb, which is backed by numbers, is that the more you're gonna let your system run for longer time for a certain task, the more you're at the risk of having a cascading error and not having the result that you want. Okay, so what gives you this ladder? We have, first of all, the simplest one, which is no model, no LLM. You have rules. If you can solve your problem with just a three-way match and you're happy, then you should use this. You should not use an LLM. Second level is a single LLM call. So it's basically RAG, so retrieval and a few examples. This is the second level. Level 3 is a workflow. This is what we discussed in our previous episode. You have your steps, so step after step. And then here, at each step, you're going to use models, but it's still the code that's controlling the steps and the interaction. And finally is an agent, which is basically where the model basically picks the next step. It's deciding their own space of resolution, which path to go. And this one is really not easy to govern. I actually made a whole series talking about this, how to govern a fully agentic system. So it's not easy, but it's feasible, and it costs money, and it needs to be used in very precise use cases because it costs a lot of money and tokens. So you as an engineer, if you can solve it with this pretty well, then use just this for automation's sake. Then after that, if you can solve it just with this, then just use that. And after that, and finally, only use this, only have an fully agentic model if really you need it. So this is this is not from Anthropic, or this is not them telling you how to do it. This is actually my own synthesis. And what I'm saying is that what they actually say is that add multi-step agentic systems only when simpler solutions fall short. And optimizing single LLM calls with RAG and in context examples is usually enough. So it's basically my logic, but not with the ladder. But this ladder is actually very important. So put it out there. And there is independent corroboration that's coming actually from Hugging Face to the ladder that I'm mentioning. It's similar to what I'm saying, but I'll just break it down to you. Agency evolves on a continuous spectrum as you give more or less power to the model over your workflow. So that's how they introduce. Their table climbs from a simple processor, whose output does not affect the program flow, so this, to a router controlling an if-else, to a multi-step. So this is the router, this is multi-step agent that controls iteration and whether to continue, and multi-agent. Multi-agent systems are really not easy to have in production. So use with caution, of course. So here you don't have a direct mapping, but it's more or less to each their own. I think I really am very happy with this categorization, by the way. Now, the discipline that makes the ladder useful, you must be able to name the specific failure that pushed you up a rung. The rules cannot handle non-PO invoices, that is a reason. For example, I already gave you the AP example. If you have you need to make a cost analysis, meaning that, okay, if I'm going this step, how much I'm trying to predict how much money I'm gaining by doing that, whether it is in time gained, in money gained, in lack of waste, how much time I'm winning, and how much I'm spending to implement the system, of course. So this is not just engineering, this is architecture and stakeholder management and requirements engineering. And these are all points coming to this decision. Do I go up or not? Yeah. So that's a very good idea to put in head. So this is some information to keep at head from our episode. First of all, we had the largest study that we discussed of production agents, 86 deployed systems across 26 domains. Their verbatim finding: teams deliberately constrain autonomy in their production, of course. 2, the numbers underneath it: 68% execute at most 10 steps before a human steps in. 70% just prompt off-the-shelf models rather than tuning anything. And mostly, the model that you already have is well enough and you don't need to train it. So, yeah. 74% rely primarily on human evaluation, and external-facing systems are tighter still. Pre-configured retrieval, mandatory human approval, and at critical steps, fixed action sequences. That is not a lack of ambition, that is what survives contact with production. And please, this is a very important thing, contact with production. 2 failure modes on the other side. Cognition: who built a coding agent for a living, published a post called "Don't build multi-agents. There are certain things you must do to contain the potential and compounding errors. Otherwise, things fall apart quickly." And the market level version is what we call agent washing. So you actually have many people who, this is a Gartner term, and this is basically people who rebrand existing products without substantial agentic capabilities. In startups, you see this you see this generally in companies. So it's basically you take an automation, or in our ladder, level 0 or level 1, and they would tell you it's agentic, which is not true. Agentic, so actually Andrew Ng spoke about this. Agentic is a gray zone. So in our ladder, there is something that is clearly agentic, which is the multi-agent systems, and there is something clearly that is not agentic, which is the rule-based system, and everything in the middle is the stuff in the middle. And yeah, agentic is a shade of gray, as they say. So the strongest argument against everything I just said is the models keep getting better. So today's too open-ended becomes tomorrow's routine. What I'm saying by this is that METR measures the task length a model completes at 50% reliability. It has been doubling roughly every 7 months. And it's actually faster lately. This is very important. The current top estimate is about 5.3 hours of human work. So a model has 50% reliability on 5.3 hours of human work. This is very important. 5.3 hours. And back in 2024, it was actually at 20 minutes. So it wasn't even close to hours. And lots of tests, lots of use cases are crossing from here to here. So we're going from, basic matching to 2026, where you could actually build more and more multi-agent systems for different use cases. So here is the sentence to take away. The line moves, the rule does not. You still can ask, can I pre-map this? You just get different answer. Next year, then you got this year. So every year, if you have different projects, you can always ask yourself, can this be a multi-agent system, and is it worth it? And would it be smart to implement it this way? Anyone telling you the next model is obsolete makes the question obsolete, is selling you the tax, is not selling you the engineering and the really deep thought about this. Now, 3 things to keep in mind is, first of all, look at the work first. Can you pre-map it? yes or no, and name the failure. Why are you going up? And this is the end of this episode. If you like the content, I really think it's really valuable. Please like and subscribe and follow me on LinkedIn. I have from time to time some interesting thoughts. Yeah. Anyway, have a nice weekend. See you.